What's going on, Yahoo Answers? Today we're going to solve another 10 derivatives. Now this time we're tackling logarithms. And as you can see, these are the identities that we need in order to solve logarithms. First, the derivative of ln of x. ln is the natural logarithm where the base is the number e, which is 2.718281828 as we discussed in an earlier video. The derivative is 1 over x. Now, the other identities are identities that apply to any log base, but most of these are important in the ln world. We're going to tackle them in ln form, the natural logarithm. So ln of xy, which is the product of x and y, is equal to ln x plus ln y. That means you can split products together within logarithms. Similarly, ln x over y is equals to ln x minus ln y. And then the third formula here is the change of base formula. Log base a of x is equals to ln of x, which is the input, over ln a, which is the base. Again, you can apply this to any base you want, but ln is the one that we are going to need a lot in this derivative session. The next is e to the ln x is equals to x. This is actually the function inverse rule, where if you have a function and then inside of it is the inverse, you get the input. So e to the ln x, function and inverse, then you combine them together, you get the input. And then the last one is the bringing the power to the front. So ln of a to the b is equals to b times ln a. You can bring the power to the front. No need to minus 1 here. We're not doing derivatives yet here. Well, we're going to be using these as we go on in our journey. Again, the 10 question files are in the description below. So answer them alongside me if you want, or you can answer them in your own time. Anyway, on to question number 1. Hold on. Y, let me just, y is equals to ln of x squared plus 3x minus 9 over 2x minus 1. Now you think this is a chain rule situation and then a quotient rule situation, but we're not going to do quotient rule because that's going to be difficult. Instead, we're going to separate the logarithms together. So what we're going to do first is look at the first one. This is going to be ln of x squared plus 3x minus 9. Look at the second one. That's a minus ln of 2x minus 1. And with that move, we instantly made it much easier. Alright? So the derivative now becomes, well, the derivative of the ln is 1 over x. So it's 1 over something. So let's put the denominator first. This is the denominator, x squared plus 3x minus 9. Now the numerator is 1, but we have to multiply it by the derivative of the input because of the chain rule. Again, output, this is the outside, and then this is the inside function. All right, so we have to find the derivative of this. So it's going to be 2x plus 3 minus, we're going to find this is the denominator, 2x minus 1, and then at the numerator we have the derivative of 2x minus 1, which is going to be 2. So that's the answer. It's much easier that way, you know. Number 2. Log base 2 of square root of x cubed plus 9. Normally, square roots would be annoying to deal with, but because of the properties of logarithms, we can bring the square root outside. How can we do that? Here's how. So we do know y equals. We do know that this is equal to log base 2 of x cubed plus 9 quantity to the power of 1/2. The square root and to the power 1/2 are the same thing. So we can bring the 1/2, the power, because it is within the logarithm. We can bring the power outside. So we can do this. 1/2 log base 2 of x cubed plus 9. This isn't clean yet because it's still base 2. We need base is e, or natural logarithm. So we can change the base here, and we will get 1 over 2 ln of x cubed plus 9. But in order to change the base, we need to find the ln of the base, which is going to be 2. So that is change of base. Uh, let's rearrange it further. ln2 is a constant, so we get 1 over 2 ln2, a coefficient. Then ln of x cubed plus 9. After this is going to be finding the derivative. This is again a constant multiplier, so we just multiply here to ln2, and then we multiply by, this is going to be the denominator since it is ln. Then we have to find the derivative, that will be the numerator here. So the derivative of x cubed plus 9 is equals to like 3x squared. So combining it, we get 3x squared all over 2 ln 2, and then x cubed plus 9. And that is our answer. Question number 3. Y is equals to x to the x. Now, the problem here is that it's not of the form y equals a to the x or e to the x, as we discussed in an earlier video. This is not the form, because the one on the bottom needs to be a constant. So e is a constant, and then to the power x, a function. So this is not it. That is not it. So it's also not y equals x to the n, because this is, well, this is an x, but should be a constant. So this is a function. This is a constant. Is it? Wait lang. So this is a function to a constant, and this is a constant to a function. This is a function to a function raised to a function. So it's kind of hard to. Well, it's not. It's not exponential. It's not polynomial. It's kind of both. But how do we solve this? If only there was a way we could bring down the power. That's right. We're going to use logarithms. But first, let's find the ln of both sides. So ln of y is equals to ln of x to the x. What we can do here is actually to bring down the power, the x power, to the side. So we get ln of y is equals to x times ln x. And our lives just become easier with this. So the next step is to find the derivative, implicit differentiation. It's not that hard. So the derivative of ln y is 1 over y, and then again, then y prime here. This is a chain rule. And then x ln x. What is the derivative of that? This is just the product rule situation. So derivative of x is going to be 1 times ln x plus then derivative of then just x, then derivative of ln x is 1 over x. So again, what we did here is we found the derivative of x 1, and then derivative of ln x, which is 1 over x, and then we cross multiplied something like this. So we get y prime over y is equals to ln x plus 1. And then we multiply y on both sides. So we get y prime is equals to y and then ln x plus 1. So after this, we can substitute y here for the y here, which is x to the x. So we get x to the x and then ln x plus 1. Believe it or not, that is the answer. Yeah. Next. 4. Question number 4. ln of x cubed y, another implicit differentiation here, equals 5xy. Now, what do we do with this? Well, this is a product within a logarithm, so we can just separate it together. So we get ln x cubed plus ln y is equals to 5xy. And we can see this is the power, so we can bring this down. So 3 ln x plus ln y is equals to 5xy. So we turned it from something that looks scary to something that looks easy. So let's find the derivative of both sides. Derivative of ln x is 1 over x, then 3 is a constant multiple, so we just multiply it there. And then multiply it by the derivative of this, which is 1 over y, and then we multiply it by the derivative of y, which is y prime. And then we find the derivative of this. 5 is a given. It's just a constant multiple. And then we have to find the the derivative of this. This is a product rule situation, so let's have here. Then what's the derivative of x? Which is that's just one. Derivative of y is y prime. So we just cross multiply it together. We get y plus x y prime. That's it. That's a trick you could do. And then next step, we have to isolate everything that has y prime on the one side. So we get y prime 1 minus y, and then we subtract by 5 times x, so 5x equals, well, we put this to the other side, so we get let's put the 5y here minus 3 over x. So in order to get no, we have to do it later anyway. So let's find y prime by dividing this on both sides. So we get 5y minus 3 over x over 1 over y minus 5x. The problem here is that it's a, well, it's a complex fraction, so we need to multiply it by the denominators here. So we multiplied both the numerator and the denominator by xy, so we can get rid of the offending complex fraction there. So y prime is now going to be 5xy squared minus 3y over x minus 5x squared y. Yes, that is the answer. Alright. Question number 5. Y is equals to ln x. Find the point where the slope is parallel to y is equals to 1/2 x plus 4. So we're trying to find the slope here, and the derivative is the slope, so we just have to find the derivative first. So let's find the derivative of this. Y prime is equals to the derivative of ln x is just 1 over x, as we talked about earlier. And so that is the derivative, that is the slope function. So, and then what? This should be the slope. So y equals mx plus b. M is the slope. Right? So in here, 1/2 x. 1/2 is the slope. So this is going to be the slope. So this needs to be 1/2. Alright? And it's pretty easy what x needs to be here. X is 2. Right? So x is 2, and then what's the value of y? Well, let's just look back here. So y equals ln of 2. So the point where the slope is parallel to y equals 1/2 x plus 4 is going to be 2 ln 2. The answer. Just remember the key terms here, that the slope and the derivative are the same thing. So that's what that's good. So when you're tasked with finding the slope, find the derivative first. It may help you. 6. Y equals ln of secant x. Yes. This is a we need to find the second derivative of this. So you know. So what's the first derivative of this first? So well, y prime is equals to 1 over secant x first, so we need to prepare that. And then the derivative of secant x is secant x tangent x, which is something we discussed earlier. So we can remove secant here. We get tangent x on its own. So the derivative of that is secant squared x, as we discussed in the previous video. So that is the answer. Seven. Y is equals to x ln squared of x. Find y triple prime. Alright. Alright. So product rule situation. So no need to panic. So y prime first is equals to derivative of x is 1, then ln squared x, that's the derivative of that is going to be 2 ln x over x. 2 ln x to the power 1, so just ln x over x. So find the, just cross multiply this, we get, well, x times 2 ln x over x is just going to be 2 ln x, and then ln x times 1 is plus ln squared x. Alright, y double prime is equal to, this is going to be 2 over x plus ln squared x, that is going to be 2 ln x over x, and then we get y triple prime. Well, here we can combine the 2 over x and 2 ln x over x here, so we get 2 plus 2 ln x over x, or we can get 2 times 1 plus ln x over x. That is also a possibility. So we can start finding the derivative of this thing. As we get 2, then we multiply by the derivative of this. So what's the derivative of this? Well, this is a quotient rule situation, so the bottom should be x squared. The formula for the quotient rule is u prime v minus u v prime over v squared. So u prime is the numerator, was the derivative of the numerator is just 1 over x, and then the denominator is just x. Multiply. Minus u is 1 plus ln x, then multiplied by the derivative denominator, which is just going to be 1. So that's good. Next, we this cancels out, so we get 2, then 1 minus 1, distribute the minus, so it's minus ln x over x squared. And then we get 1 minus 1 cancel, so we get negative 2 ln x over x squared. That's the answer. Y squared, oh, this is number 8, equals ln of y ln x. So this is another implicit situation. So what we're going to do is just to find the derivative of both sides, just normal. So derivative of y squared is 2y, and then y prime, chain rule. So we get the derivative of this is 1 over y ln x. Then chain rule, we have to find the derivative of the inside. So y and then ln x. Derivative of y is y prime. Derivative of ln x is 1 over x. Cross multiply, we get y over x plus y prime ln x. So it's going to be the derivative. So let's isolate everything that has y prime to one side. So y prime to y minus y prime ln x. Oh, hold on. Before we do that, actually, let's just try to simplify this first before we do anything. Actually, I can find a simplification here. 2y y prime is equals to this y and y cancel each other out, so it's 1 over x ln x plus this one, the ln x cancel each other out, so it's y prime over y. So we just transfer it to the other side, so we get 2y y prime minus y prime over y is equals to 1 over x ln x. Isolate y here. Isolate y prime here, sorry. Y prime of 2y minus 1 over y is equals to 1 over x ln x. So what we get here, y prime now is equals to 1 over x ln x over 2y minus 1 over y. To prevent complex fractions such as this, we multiply both numerator and denominator by this. Yx ln x, then yx ln x. Something like that. So we multiply the numerator by that, so we get numerator is going to be y over, the bottom is 2y, Well, let's start with x. I want x. Xy squared ln x minus x ln x. And that's the answer. Yeah. Sorry. Question number 9. It's a bit similar from question number 3, but a bit different as well. Y is equals to x to the y. Now, x is a function, y is a function. So, x to the y is a function to a function. So, we can use ln here in order to make our lives easier. So, ln of both sides, ln y is equals to ln of x to the y. We can bring y down, so we get ln of y is equals to y ln x. We're going to find the derivative of this. This is just product rule situation. So first on the left, ln y is 1 over y. Then we multiply it by y prime. Since it's chain rule, the derivative of y is y prime. So this is a product rule situation. So y and ln x. Derivative of y is y prime. Derivative of ln x is 1 over x. Cross multiply, we get y prime ln x plus y over x. Let's put everything that has y prime to one side. So we get y prime over y minus y prime over ln x is equals to y over x. I said y is 1 over y minus ln x is equals to y over x prime. So y prime is now equal to y over x over 1 over y minus ln x. Multiply both numerator and denominator by xy to prevent any complex fraction situations here. So we get this is going to be, well, x and x cancel, so y squared over the bottom, y and y cancel, so it's going to be x minus xy ln x. That is the answer. Number 10. Y is equals to ln of cube root of x squared minus x plus 1 over 2x minus 1 squared. Now, you could do a chain rule, quotient rule situation here, but we're not going to do any of that. Instead, we're going to use, again, we're just going to use logarithm identity. Here, we can separate these numerator denominator together using the subtraction one. So ln of cube root of x squared minus x plus 1, and then minus ln of 2x minus 1 squared. This cube root is equivalent to the power 1/3, so we can put it outside. 1/3 ln of x squared minus x plus 1 minus 2 times ln of 2x minus 1. The derivative of that is just simple. This is 1/3, and then this is the denominator, so x squared minus x plus 1. Then numerator is going to be 2x minus 1 minus 2 ln of 2 times, hold on a minute. So minus 2 times 2 over 2x minus 1. The 2 here is the derivative of the inside. So simplify, we get 2x minus 1 over 3x squared minus x plus 1 minus 4 over 2x minus 1. So after this, we can simplify this even further. Now for this one, we're going to simplify it. So the denominator is going to be the LCD, which is 3 multiply x squared minus x plus 1 multiply 2x minus 1. So that's it. So we need to multiply this towards there. So this is going to be 2x minus 1 squared minus, this is 4 multiplied by this going there. So we get 4 times 3 times x squared minus x plus 1. Then we get 4x squared minus 4x plus 1, which is this. Then minus 12x squared, so minus 12x squared minus 12 minus x, so that's positive 12x. Then minus 12 times plus 1, so minus 12. That is going to be over 3 of x squared minus x plus 1, 2x minus 1. Let's move this up again. So now this the final answer is going to be 4x squared minus 12x squared negative 8x squared. The negative 4x plus 12x is 8x. 1 minus 12 is minus 11 over 3 multiply x squared minus x plus 1, then multiply by 2x minus 1. And then that is the answer, but you can also simplify this using just putting the negative outside. So negative of 8x squared minus 8x plus 11 over 3 times x squared minus x plus 1, then 2x minus 1. And that's the answer. And that's the end of this entire thing. I'll see you all in the next video. Bye.